Welcome to the Fundamentals of IPOSplus. This is an online version of a class that SEW Eurodrive occasionally holds as a live class on site. We're making this available for both SEW Eurodrive employees and customers who wish to learn a bit about IPOSplus programming. So let's dive in and have a go. My name is Don Congdon. I'm a corporate trainer at SEW Eurodrive. I created this class and I teach it when we do it on site, so I hope you'll find this interesting and helpful. First of all, what is IPOSplus? IPOSplus stands for Integrated Positioning and Sequence Control System. That's a rather fancy name for a built-in programming system found in several SEW Eurodrive products, and it lets you take full control of the product for maximum flexibility. By the way, at SEW, we rarely call it IPOSplus. We usually just call it IPOS. So that's what I'll be calling it as we go along, but that is its official name, so you'll see that in the different slides. Now, before taking this class, there are a number of things that you should be aware of. First of all, you really need to complete the MoviDrive B intermediate training. We'll be using a MoviDrive B for this class, and you do need to have a good solid understanding of that VFD. You need to be comfortable with things like working with the parameter tree, commissioning a drive so the motor can operate, connecting things up to it, and interacting with its I/O. Now, if you've already taken a MoviDrive B class, you're all set. SEW offers these both online and on-site. If you've taken either form, you're good to go. If not, however, I would suggest you stop right now and take the online class that we offer on our YouTube channel. You can see it right here, MoviDrive B Intermediate Training. This is identical to the in-person class that we teach at SEW. So I would suggest you stop and work through it. Now that will take a little while, but it gives you information you really must have before you can take this class. But assuming that you're up to speed in MoviDrive B, then let's go ahead and move on. You're also going to need a demo unit or trainer in order to get the full advantage of this class. Now, if you don't happen to have one, of course, you can just watch the class and follow along, and you'll learn a great deal. But for maximum effect, you really do need a demo unit or trainer. If you're an SEW Eurodrive employee, please contact the training department because we have demo units that we can make available to you. If you're a customer, you're pretty much on your own. You'll have to get a demo unit in some other way. Either borrow one from an SEW Eurodrive representative or work with a MoviDrive B that you happen to have at your company. Now, here's what you need to be able to work through this class, assuming you don't have a demo unit. You need a MoviDrive B. It doesn't really matter what size it is. You also need some kind of a motor with a built-in encoder or resolver. This can be an asynchronous motor or, as shown here, a servo motor. It doesn't really matter. Either will work just fine. But you do need that encoder or resolver because a lot of the things you do in IPOS involve positioning, which requires an encoder. You'll also need a control box connected to the I/Os on the drive. And you really do need an expansion I/O card as well, so that you'll have enough I/O for the example programs. You'll need a USB adapter of some kind, either a USB 11A, which is the older adapter, or a USM21A, which is the newer one. Either one will allow your computer to communicate with the MoviDrive B easily. You'll need an Ethernet IP Fieldbus card. Now, this is optional. We only use this for the very last activity in the class, and if you don't have one, you can just watch that video and follow along. But if you've got one, it will definitely enrich your experience. And then finally, you'll need a computer loaded with MoviTools Motion Studio, which is the software used to control the MoviDrive B, to commission it, to work with it. This software is free and easily downloadable from SEW Eurodrive's website. I also strongly recommend that you have some programming experience. Now, you don't have to be an expert at programming, but you should have had some background where you've done a little programming in some setting. For example, if you know C, C++, C#, Java, JavaScript, Python, or even structured text on a PLC, then you've got the background to be able to take this class. If you don't really have any programming background at all, you will probably struggle with this class, because I'm not going back to the very beginning to explain every key idea of programming. I'm going to be focusing on things that you should probably already understand to some extent. Now, everything we do in this class falls into one of two categories. The first is details involving the IPOS programming language. I call this the underlying structure. It's kind of like the bedrock upon which everything sits. Because in order to be an effective programmer, you have to be able to understand the language and its features. So about half this class is going to involve just learning the language. And then we'll move on to what we do with the language, which is motion control. That's the whole point of IPOS, to control your Movi Drive B and make it do things. So this is what you're actually trying to do. It's really the things that sit on top of the bedrock and make the motion, the exciting things, the interesting things. So these are the topics we're going to cover. Let's talk about these. We're going to begin by studying the programming language. We'll explore what IPOS is and what it's used for. We'll look at the IPOS programming languages. There are actually two, although we're going to focus on just one of them. And we're going to go into the key features of IPOS, such as memory, variables and numbers, the I/O system, multitasking and task management, and interrupts. Now, if some of these terms mean absolutely nothing to you, don't worry about it. I'm going to define everything as we go along. This is just an overview. We'll talk about configuring a Movi Drive B to get it ready for programming. We'll overview the big ideas of programming. We'll talk about setting up a project and source file, which you need to do to begin programming. Then we'll talk about comments and compiler control, and then using the development tools. This will be the bedrock that gets us ready to program. We'll move on from there and talk about numbers. You need to understand binary numbers, hexadecimal numbers, and what a signed number is. That's a number that is either positive or negative. You'll also need to be up to speed in constants and variables, and how to name them. We'll look at debugging tools built into Movi Tools Motion Studio, which lets you work with variables. We'll talk about system variables and their different uses. We'll talk about arithmetic, logic, and bitwise operations. And we'll talk about programming debugging tools. Movi Tools Motion Studio has a lot of built-in features to help you as a programmer to solve problems and get your job done quickly. We'll talk about the built-in functions. There are about 30 of these. Decision structures, looping structures, and user-created functions. If you're already a programmer, all of these things should sound at least familiar. Then we'll move on to motion control, what we're actually trying to do with the programming language. We'll talk about referencing concepts and modes. That's a very important feature that you need to master in order to be able to perform positioning, which is mostly what you do with IPOS. We'll talk about function calls that wait and the ones that don't, and what's the difference, and why you'd use one or the other. We'll talk about the referencing function and the system variables connected with it. We'll talk about relative versus absolute positioning, and positioning functions and their system variables. Then we'll move on to multitasking, doing multiple things at once, and how you manage those tasks. There are functions that do this too. We'll talk about accessing the parameter tree in the Movi Drive B through functions, how to jog the drive, how to use the non-volatile memory, that's memory that doesn't lose its contents when power is turned off, And then we'll get into what I call kind of the senior project of the course, and that is building a state machine to implement a control system. We'll be implementing a simple control system that sort of sums up many of the things you've learned. And then we'll do a few advanced topics at the end, and you can actually treat these as optional if you'd like. We'll talk about record variables and complex data types, the built-in complex data types, how to communicate internally within the VFD and communicate between VFDs using communication functions, and field buses. You'll be writing quite a few programs, probably in the neighborhood of about 20, and they will explore each of these subjects one at a time. Now, as we go along, suddenly you'll see a screen that will say hands-on task coming up. And that's a key for you to get ready to use your demo unit to write a program. And I'll be explaining to you what I want you to do, giving you the parameters for the program. Then you can pause the video, go off and attempt it. And when you come back, I'll step through the correct program and show you how it works. And you can see if it works the way yours does. And if you get stuck, you can look at my programs and help you get unstuck. All right. Now, a handy tip. As we go along, look out for red terms. These are kind of like vocabulary words. They're important concepts that you should pay attention to, and they're usually in bold red. So when you see those, note that term. It's important. Now, why do we build a programming system into a variable frequency drive? What's the reason for IPOS? Well, let's look at it this way. If you have a VFD that does not have a built-in programming system and you need to do something sophisticated with it, chances are you're using a PLC to add some intelligence to the equation. Now, in a PLC-controlled machine, the PLC is the heart of the operation. It's connected to the VFD, maybe to an encoder or encoders, and I/O devices like switches, lights, buttons, etc. It controls everything. It's really the intelligence or the heart of the system. Now, obviously, that costs money. You've got to pay for the PLC. You've got all the wiring and the programming. And then, of course, you have to manage the VFD. On the other hand, if you've got a built-in programming system in the VFD, it's almost like having a PLC embedded inside it. So an IPOS-equipped VFD can replace the PLC entirely. It handles the I/O, the encoders, and control all on its own, sort of like this. So it takes the PLC out of the equation, reduces the cost, and in many ways makes it simpler. So advantage, eliminate the PLC, cutting costs. Now what about a bigger system? Maybe one where a PLC controls a whole bunch of devices. Well, it's pretty much the same thing. The PLC has to manage everything. So maybe we've got one PLC and a field bus with a bunch of VFDs on it, and it's also connected up to some encoders and some I/O devices. Okay, that's a pretty typical setup. But again, a lot of wiring and an expensive PLC in the equation. In a locally controlled system, programs in the VFD do most of the heavy lifting, and maybe just a little PLC does a few high-level tasks. Something like this. All right, a locally controlled system is a little simpler, and it doesn't need as much heavy lifting from the PLC because there are local programs running in the VFD. So again, the advantage is the smaller PLC and probably less wiring, which means less cost and less to go wrong. Few facts about IPOS. It's built into several SEW Eurodrive products, not just the MoviDrive B, but that is the one that it's usually used in. It's also found in the MoviTrack B, the MQ series field bus modules, and the MoviGear and DRC motor of the B generation. It's also in some discontinued products, which we won't talk about since they're discontinued. It is not a part of any new product. So the C generation, Movi C, including the new MoviGear and intelligent motors, they do not include it. That product line has gone a different direction. You use MoviTools Motion Studio, the development software that is available free for SEW's B generation products. There are two programming languages available, assembly and compiler. These are two different ways of programming, same goals in the end, but different style. We will be focusing on compiler, but let's talk about assembler briefly. Assembly language is a way of programming. It is the native language of IPOS. It's very low level. You have to give a lot of tiny little instructions to make things happen. You can see an example here on the left. Each line is a single instruction to the processor built into the MoviDrive B. An instruction does something very, very basic. So you need lots of them. And you have to think in very tiny steps. The code is not very readable by most people. Some people love assembly language. I do, actually. But it's not a very friendly language, and a lot of programmers don't really like it. But the programs are efficient and fast. And you can recover the original program from a VFD. For example, if a customer has an IPOS program written in assembly language and they no longer have the original file, you can pull this out of the VFD and figure out how it works. Now, the compiler language, by contrast, is based on an industry standard programming language called C, which you may have heard of. It's a major language in industry, and it has many descendants with the letter C in there somewhere. It's a medium level way of programming. You can see some IPOS code, which looks like C code, and it's pretty readable. Each line becomes many processor instructions, not just one. So one line of code can do something very complicated, which is not true in assembly language. Programs require fewer lines of code. You get to think in larger conceptual steps, not teeny little steps. And most programmers with any experience can read the code and figure out what it's doing, even if they don't know the language very well. But the programs aren't quite as efficient or fast, although they're still pretty good. However, if you do not have the original source file for a program written in compiler, you can't recover it from the VFD. You can't pull the code out of the VFD. It's just not there. Now, you've heard me use the term source code a number of times, and I'd like to explain that in a little more depth. If you don't really understand what that is, let's look at how a program gets created. We start with what's called the source code. It's a simple text file. This is an assembly source code program. You can see it's just plain text. It's not very readable, but it's simple text. And you can create this with any text editor, like the Notepad in Windows, for example, or the editor that's built into MoviTools Motion Studio. This is the source, your basic program that you write. Now, to put it into a form that the VFD's processor can execute, we have to convert it into what's called object code. And we do that with a program called an assembler. It's built into MoviTools. It takes the source code, it crunches it, and outputs what's called an object file. That's a file that's just a bunch of numbers. Object code is executable code. It's what the processor and the VFD can run. So that's kind of the idea. Do be aware, with an assembly program, there is a one-to-one relationship between the instructions in the source code and the numbers in the object code. Now, on the other hand, a compiler program is a little different. Again, you write the source program in a text editor. It's just plain old text. But it runs through an extra step. It runs through a program called a compiler, which is also built into MoviTools. The compiler converts the text into an assembly language program, which is then fed into the assembler, which in turn outputs the object code as a file of numbers. So it's really a two-step process. There's one more layer involved. Do be aware there is a one-to-many relationship between the program lines in the source code and the numbers in the object code. A single line of IPOS C code could turn into maybe dozens of lines of numbers. That's just the way it works. All right, now I've mentioned the idea of recovering your source code. What do I mean by that? Well, the idea is that it is possible to extract the object code from a VFD. Let's say a customer has had someone write an IPOS program long in the past. They've lost the original files, but the VFD itself still contains the IPOS program, which is running and doing its job. Well, you can go to the VFD, you can download that object code out of it. And if it was an assembly language program, you can turn it back into source code. There's a program called a disassembler that does this. Now, it won't be very readable because the things the original programmer put in there, like comments and special formatting and shortcuts, those will all be missing. But the core code will be there, and if you're a good assembly language programmer, you can figure the program out, make changes, reassemble it, put it back into the VFD. So that is an advantage of programming in assembly language. On the other hand, you can't do this with compiler programs because compiler programs have that two-step process. So while you could disassemble it and turn it back into assembly code, it would be virtually unreadable and unusable because there's no way to turn it back into source code. There's no such thing in this environment as a decompiler. Okay, so that means that if you write IPOS compiler programs which have that C code structure, it is really important to keep a safe copy of the original code if you ever expect to change your program again. If you don't keep a copy, you're just out of luck and someone will have to rewrite that program from scratch. Now, assembly language is the coolest way on the planet to program, and yes, I'm very biased. I love assembly language, but we won't be doing it in this class. Instead, we're going to focus entirely on the compiler language. Very few programmers use assembly language these days, so learning it wouldn't really be the best use of our time. On the other hand, the compiler language is very popular, it's very easy to understand, we'll get a lot more mileage from it. So do be aware about what assembly language is, but don't expect to really be interacting with it. This is about the last you're going to hear of it. A few important notes. First of all, IPOS's capabilities, how much memory it has, how powerful it is, what it can control, varies from product to product. It just depends which SEW Eurodrive VFD you're running IPOS on. Some products can do a lot more with it than others. The most capable version is found in the MoviDrive B, and therefore that is what we're going to study in this class. We will not be talking about the MoviTrack or the field bus distributors or the MoviGear or anything like that. We are going to focus entirely on MoviDrive B. And if you are interested in some of those other products, you're going to have to kind of study that one on your own. So the IPOS manual, which is downloadable from SEW Eurodrive's website, does talk about the other products. So there is information out there, and what you learn in this class will broadly be applicable, but we're not going to really deal with it. Also be aware, even though MoviGear and the DRC motors do include IPOS built in, they're really not supposed to be programmed. IPOS is included for SEW's internal use. We really don't want customers writing their own IPOS programs. We don't really encourage SEW employees to write IPOS code for these products for customers. It's really in there for internal use only. So you really shouldn't even think of those products as even containing IPOS. Now, this book is kind of the IPOS Bible. It's the IPOS manual. It's downloadable as a PDF. And I would just say if you want to know everything there is to know about IPOS, read it cover to cover. It's actually not that long a read. It's actually pretty intelligible, and it is very helpful. So that, of course, is the ultimate go-to. Now, a little warning, hazards ahead. My wife and I took a trip to Iceland a number of years ago, and there are roads in Iceland, they call them F-roads, and they have these warning signs on them because if you take an ordinary car on an F-road, you could very well destroy it. They're kind of hazardous, and you generally need all-terrain vehicles to take an F-road. So learning IPOS is kind of an F-road condition. It is sophisticated, powerful, but you can definitely get yourself into trouble if you don't know what you're doing. So I'm just giving you that little warning. I'm sure you're probably going to ignore it because you probably have the itch to learn IPOS. It is really a neat programming environment. But just ask yourself the question, before writing an IPOS program, do we really need to write an IPOS program, or are there alternatives that are quicker, easier, and a little more bulletproof, such as the application modules that are available for the MoviDrive B? These are canned applications that handle many common situations found in industry. They're well tested, well debugged. They do a great job, and in many cases, they would be a much better choice. And in most cases, they can be configured in just a few minutes or under an hour. So ask yourself, will an application module do what you need? Don't reinvent the wheel if you don't have to. But if the application modules don't do what you need, by all means, move forward, use IPOS. Now, if you have any questions as you go through this course, whether you're an internal employee or a customer, you are welcome to contact us and ask questions. Specifically, contact the training department. You can see the email address there. It's a really easy one, training@seweurodrive.com. And please include IPOS class in the subject line so we know what it is and can be routed to the correct person. All right. That's the end of the introduction. So I'll see you when we move into session number 1 of learning how to program IPOS.